CRS-23 Mission explains. Hello, lovely YouTube family. Welcome back to Tech Power. In today's video, we're going to talk about CRS-23 Mission Explain. Before we start, I would want you to hit that red subscribe button so that you never miss out on any of our videos. SpaceX CRS-23, also known as SpaceX-23, is a commercial resupply service mission to the International Space Station, successfully launched on 29 August 2021 and docking the following day. The mission was contracted by NASA and was flown by SpaceX using the Cargo Dragon C208. This was the third flight for SpaceX under NASA's CRS phase to contract awarded in January 2016. A NASA Flight Planning Integration Panel from 2019 indicates that SpaceX cargo missions will begin to extend their duration to 30 days and beyond, starting with CRS-23. Cargo Dragon, 30 August 2021, International Space Station configuration. 5 spaceships are parked at the space station, including the Northrop Grumman Cygnus and G-16 space freighter, the SpaceX Crew 2 and Cargo Dragon CRS-23 vehicles, and Russia's Soyuz MS-18 cruise ship and ISS Progress 78 resupply ship. SpaceX plans to reuse the Cargo Dragon up to 5 times. The Cargo Dragon will launch without Super Draco abort engines, without seats, cockpit controls, and the life support system required to sustain astronauts in space. This newer design provides several benefits, including a faster process to recover, refurbish, and refly versus the earlier Dragon CRS design used for ISS cargo missions, along with SpaceX Crew 2, Endeavour, and Inspiration 4 Resilience. 3 Dragons are scheduled to be in space during the same period from 15 to 18 September 2021. The new Cargo Dragon capsules are under the NASA CRS Phase 2 contract, will splash down under parachutes in the Gulf of Mexico. Payload. NASA contracted for the CRS-23 mission from SpaceX and therefore determines the primary payload, date of launch, and orbital parameters for the Cargo Dragon. Science investigations: 1,046 kg. Vehicle hardware: 338 kg. Crew supplies: 480 kg. Spacewalk equipment: 69 kg. Russian hardware: 24 kg. GIDI S1 Robotic Arm Tech Demo. The GIDI S1 Robotic Arm Tech Demo will test the GIDI Japan Integrated Network Control System microgravity robot by placing the arm inside the newly added Nanoracks Bishop airlock, which was carried to the station by Dragon C208 during the SpaceX CRS-21 mission last year. Once inside the airlock, the arm will perform numerous tests to demonstrate its versatility and dexterity. Designed by GIDI Japan Integrated Network Control System, the robot will work as a general-purpose helper under the pressurized environment inside the Bishop airlock. It will operate tools and switches and run scientific experiments. The next step will be to test it outside the ISS in a harsh space environment. The robot will be able to perform tasks both autonomously and via teleoperations. Its arm has 8 degrees of freedom and a 1-meter reach. GIDI S1 is a semi-autonomous and semi-teleoperated robotic arm designed to conduct specified tasks internally and externally on space stations, on-orbit servicing, and lunar base development. By combining autonomous control via AI and teleoperations via the specially designed GIDI manipulation system AH1, GIDI S1 on its own possesses the capability to conduct generous purpose tasks, manipulation of switches, tools, soft objects, conducting science experiments and assembly, high-load operations, etc., that were extremely difficult for industrial robots, such as task-specific robotic arms, to do. NASA Glenn Research Center studies: flow boiling and condensation experiment, insert for the fluids integrated rack, support hardware for solid fuel ignition, and extinction insert for the combustion integrated rack, remaining solid fuel ignition and extinction hardware to fly on SpaceX CRS-24. Student Spaceflight Experiments Program. The Student Spaceflight Experiments Program has 5 experiments manifested. Mission 14C2 Experiments. Malta sent its very first space bioscience experiment entitled SpaceX as a first mission. Under the MALIF program, the first mission will be investigating the skin microbiome of diabetic foot ulcers resistant to conventional treatment. Experiments will include a full multi-omic analysis before and after spaceflight takes place. The experiment is also taking a large number of STEM-based science messages from people, including school children of all ages, to be part of this historic first mission to the International Space Station. The specially designed BioCube, based on the ICE Cube's platform, is done in collaboration with Space Orbit Your Thesis, Oscar Q. Designed, built, and tested in a period of 14 months by a team of university students from Hasselt University in Belgium, Oscar Cube will be installed in the Columbus Laboratories, ICE Cube's facility owned and operated by Space Application Services. The team took part in European Space Agency's education program called Orbit Your Thesis and proposed the experiment, which is a diamond quantum-based magnetometer with femtotesla precision. The team are the first to launch their experiment as part of the OYT program and are the first students from their university to launch an experiment to the ISS, building bone with byproducts. Reed Foreign Policy evaluates the effects of microgravity and space radiation on the growth of bone tissue and tests whether bioactive metabolites, substances such as antioxidants formed when food is broken down, might protect bones during spaceflight. The metabolites tested come from vegetal extracts generated as waste products in wine production. Protecting the health of crew members from the effects of microgravity is crucial for the success of future long-duration space missions. This study could improve understanding of the physical changes that cause bone loss and identify potential countermeasures. This insight also could contribute to the prevention and treatment of bone loss on Earth, particularly in postmenopausal women. Sourcing metabolites from materials that otherwise would become waste is an additional benefit. Keeping an eye on eyes. Retinal diagnostics tests whether a small, light-based device can capture images of the retinas of astronauts to document the progression of vision problems known as space-associated neuroocular syndrome. The device uses a commercially available lens approved for routine clinical use and is lightweight, mobile, and non-invasive. Videos and images can be downlinked to test and train models for detecting common signs of SANS in astronauts. The investigation is sponsored by the European Space Agency, with the German Aerospace Center Institute of Space Medicine and European Astronaut Center. SANS is present in over two-thirds of astronauts and thought to be associated with long duration, 30 days or longer, exposure to microgravity, said Principal Investigator Julian Drescher of the Department of Land Resources. Currently, visual problems that may manifest from SANS are mitigated by providing glasses or contact lenses to crew members. Multi-year missions to Mars may worsen these symptoms, and there is a need for a mobile device for retinal image diagnostics. While developed for space, this mobile technology has the potential to provide diagnostics in remote and extreme environments on Earth at a reduced cost. Mobile biomedical diagnostic devices such as these will likely emerge as both an enabler of human deep space exploration and a sustainable model for healthcare on Earth. Robotic helpers. Nanorack's Gidai robotic arm demonstrates the versatility and dexterity in the microgravity of a robot designed by Gidai Japan Integrated Network Control System. Results could support the development of robotic labor to support crew activities and tasks, as well as servicing, assembly, and manufacturing tasks while in orbit. Robotic support could lower costs and improve crew safety by having robots take on tasks that could expose crew members to hazards. The technology also has applications in extreme and potentially dangerous environments on Earth, including disaster relief, deep-sea excavation, and servicing nuclear power plants. The experiment will be conducted under the pressurized environment inside Bishop Airlock, the space station's first commercial airlock. This technology demonstration is to show the world that the capabilities necessary for automation in space are finally available, said Company Chief Technology Officer Toyotaka Kazuki. It provides an inexpensive and safer source of labor in space, opening the door to the true commercialization of space. Putting materials to the test. Miss 15. NASA is one of a series of MISS investigations testing how the space environment affects the performance and durability of specific materials and components. These tests provide insights that support the development of better materials for future spacecraft, spacesuits, planetary structures, and other components needed for space exploration. Testing materials in space has the potential to significantly speed up their development. Materials capable of standing up to space also have potential applications in harsh environments on Earth and for improved radiation protection, better solar cells, and more durable concrete. Alpha Space provides the MISS FF lab that hosts these investigations. MISS 15 includes tests of concrete, spacecraft materials, fiberglass composites, thin-film solar cells, radiation protection materials, a micro-optical chip, 3D printed polymers, and more, said MISS project engineer Ian Karcher. In addition, the availability of this platform for commercial technology development contributes to the ongoing commercialization of space and development of new space technologies. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.